Well, hello, my friends. Let me give you a quick tutorial on the TINA from Texas Instruments Electronic Circuits Simulator software. Once you download and open the software, you will see this desktop. And my recommendation, it is very intuitive. You have your basic Microsoft tabs up here for file, for opening, closing, saving, edit. You have insert, and we will be inserting text in a little bit. You have view, you also have analysis and tools. So these are basic menus that are available from Microsoft for file, edit, insert, view. Analysis and these other ones are new for this particular piece of software. On the bottom, you also have tabs for basic components, switches, meters, sources, semiconductors, and such. We'll stay with basic and show you very quickly how we build our circuit. Now I'm going to take and grab this guy and put this guy down here, and I notice it's rather small. My regular magnification is at 100. I'm going to change this to 200, make it a little bigger for us to see with a better sense of resolution, and take and grab another one and place it here, and take a source and grab it and place it here, grab a ground and place it here. And now R1 is 1 k ohm, R2 is defaulted as 1 k ohm as well. Double click this fellow and we should be able to change this to some value. I think for this particular exercise, I'm going to make this 3.3 kilo and hit enter. And for this particular one, I'm going to make this a 2.7 kilo and hit enter. So altogether, I have 6 kilo ohms. The voltage source is defaulted as 5, as you can see. I'm going to change this to 4.5. That's the size of your battery packs, those of you who are using battery packs for powering your circuit boards. Now, if I wanted to insert yet one more, I could insert one more over here. I could rotate, 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 rotate. And the rotation allows me to have a different orientation of my schematic. So I can have 1, 2, 3 resistors, and they automatically name each subsequent resistor in numeric order. So this was recently inserted. That's why it became R3. I just wanted to show you that, yes, if we advance our drawings to have different orientations of resistors, then the rotation is very easily done with this over here or this side, depending on which way you want to rotate. Since we're not going to use the third resistor and it's selected, I'm just going to hit the delete button. Now, to hook up the wiring is very simple. The mouse pointer is an arrowhead. Notice at the end of each of these components is a little red X. The little red X are connection points. So I'm going to connect from here to here. That's kind of a weird connection. Come on, let go. If I didn't like that, I can select it and hit delete. I can do this over again from here to here. Okay, that's a nicer looking wire from here to here, and from here to here, and from here to there. Great. And if I want to give a little more space to this, I can click this wire and drag it out a little further this way. Now, once you've done the wire connections, you want to make sure that everything is electrically connected and not just visually connected. And you can do that very easily by selecting a component, nudging it up. Do the wires go with the unit? Yes, they do. Bring it back down, select the next component, nudge it up. Do the wires move with the component? Yes, they do. Bring it back down, bring the voltage source, move it out. Do the wires go with it? Yes. So that means you not only have a visual connected set of wires, they are electronically connected. So now let's go ahead and bring in some meters. So go ahead, select the meters tab. We'll bring in a voltmeter. Now notice that it has 2 wires, one at the top and one at the bottom. It's kind of awkward to hook up across R1 this way. So I'm going to rotate this guy in this fashion. And notice that I have the positive side of the voltmeter, meaning the red lead on the left, and I want to attach that to the positive side of the first resistor, connect and attach that to the negative side of the first resistor, bring in another voltmeter, and I also have to rotate this and bring it in place and bring it down to here and bring this guy down to here. Yes, I wanted to bring in an amp meter. So actually, let me select this wire, deselect it. Let's bring in an amp meter. Rotate this guy this way because I want the negative side of the amp meter facing the negative side of the voltage source there, and this side of the amp meter up to here. Yay, all right, this is great. Now I'm going to do an analysis. Let's see, before I do analysis, we can do this. I want to insert a text box, and the text box will read series 2R by I'm a sample and date 3-20-20. You'll be typing in your name, of course, and hit the little font box and the little font button. I'm going to change to Arial rounded MT, and let's make the 16-point type. Hit OK, hit the green check mark, and I can place the little title box there. Now I'm going to go to analysis and DC analysis, table of DC results. And here we are, my friends. Actually, I don't want this. I want to do some calculations first, and we can do this with our calculator because we're supposed to use the DC analysis to double check our calculations. So how do I calculate current? Remember, current is voltage over total resistance, yes? So my total voltage is 4.5, and my total resistance is 6 k ohms. So I should have a current that is engineering 750 microamps. Now keep that in mind, 750 microamps. And with that, I can multiply that current times the ohms of a resistor to get the voltage. So it looks like of my 4.5 volts, 2.475 volts will be dropped across R2. So 750 microamps and 2.48 volts across R2. Let's see if our analysis with our calculation is correct or not. So we go ahead and bring in the analysis box. Let's go ahead and show all the values, and look at this, 750 microamps as we predicted, and 2.48 volts for VR2 as we predicted. Pretty snappy. So now you're ready to do a snip. So you go ahead and hit the snip button. You go ahead, hit new, and while everything is grayed out, go ahead and select the portion of your TINA circuit that is significant, which is this part here. And then you do edit, copy. Then you can go ahead and minimize the screen, open up a Word document, and blank. And then Control V for paste, do a file, save as, and save in the appropriate folder. And we will call this a series 2R by your name. I'm just going to type I am a sample and hit save. And now the document is ready to upload into Canvas, and that's how you receive your grade for a completed exercise and analysis. So with that, that completes our quick tutorial. And if I didn't have to stop and chat with you about this, the actual build of this will probably take less than 3 minutes to do the build, the analysis, and the box. So let me go ahead and hit stop recording. So with that, have a lovely day.